Okay, guys, so in general, obviously our overall goal with any of these system solving methods is to be able to find the one ordered pair that makes both of the equations true, or the one ordered pair where our two lines, if we were to graph them, would cross. But if we get down into the nitty gritty of how we do each method, and we look at substitution that we did last class, what was the nitty gritty first step of substitution? Yeah. Yeah, we were plugging it in. So you're telling me, I know this is mind blowing, but you guys are telling me for the substitution method, the first thing we did was substitute, right? Yeah, right? I know. It's crazy. What do you think we're going to do with the elimination method? Yeah, we're going to eliminate. Okay? So, in general, we don't like seeing equations with x's and y's because we can't solve them, right? I can't get down to x equals a number or y equals a number. With substitution, our method allowed us to substitute something in for one of the variables so that we had just x or just y to solve for. Okay, here with elimination, we are going to either eliminate x or eliminate y. All right, somebody just, and you guys can just yell these out. Give me a pair of numbers that when I add them, they would go away. They would eliminate. They would be 0. What'd you say? 10 and negative 10. When I add those together, they eliminate. What else? Yep. 5 and negative 5. 6 and negative 6. Any pairs of opposites, right? Opposite numbers eliminate each other. So as I am looking at a problem and I'm approaching a problem, an elimination problem, I want to look for opposites on either the x's or the y's. Okay? So let's look at example 1. So in example 1, do you see any opposites? Yeah, negative 6y and 6y. Okay? So I know that if I add negative 6y and 6y together, they are going to eliminate. Okay? So since I have opposites, I'm going to go ahead and add down. Okay, and I'm going to combine like terms, just straight down. So it is important, guys, when we approach an elimination problem, we make sure that they're lined up. X's over X's, Y's over Y's, numbers over numbers. So that now, as I add down, I can combine like terms pretty easily. So what's 5x plus 3x? 8x. And then negative 6y plus 6y is gone, right? So that's what we want to mark out. That's what we eliminated. Bring down your equal sign. And then negative 32 plus 48? Yep, 16. Does that look a little easier to solve? Yeah. And I will tell you, they're kind of flip-flopped. On substitution, the first half, finding that first number is usually more challenging than finding the second number, right? Because we just plug it in. With elimination, it's kind of flip-flop. Finding the first number is generally pretty easy because we're eliminating stuff out. We're making it a smaller problem rather than a bigger problem. But the second half is a little more challenging just because of the math involved. So now solve what's left. So I divide by 8 on both sides. And I end up with x equals 2. And hopefully you guys remember from last time that this is only half of the answer, right? The solution to any system is going to be an ordered pair. So I need to come over to this side, and I'm going to find the second half. And we're going to find the second half very similarly to how we found the second half on substitution. I'm going to take the value that I just found, and I'm going to plug it into one of my two original equations. So you guys tell me that from the two original equations, do you think the top or bottom equation looks easier to plug x into and solve for y? Bottom? Yeah, sure. Why not? There's not negatives. I like that, right? So that's something I might look for. So, okay. So let's use this bottom equation right here. And we're going to plug x equals 2 in. So I have 3 times x, which is 2, plus 6y equals 48. So I literally just rewrite that equation, but I substitute the 2 that I know in for x. So now let's go ahead and solve. So 3 times 2 is 6. So now my opposite operation, I subtract 6 from both sides. I get 6y equals 42. divide by 6, and I end up with y equals 7. So now my ordered pair is going to be 2, comma 7. Okay? So look for opposites, eliminate, solve what's left, and then from there it's just substitution. Yes, sir?
So it's pretty much the same thing as the other one, but just like different way of finding the points.
Yeah, so it's a different method of finding the same answer. Yeah, because if I took this equation and I manipulated it around a little bit and I did substitution with it, I would still get the answer 2-7, right? Because the system doesn't change, so the answer is not going to change. It's just the solving method that changed based on how the problem is presented to us. Because remember on warm-up, that last problem did not have an x equals or a y equals on it. So it wasn't really set up, it wasn't really conducive to substitution. So I would use elimination. Some of these problems, if it has x equals or y equals, that's conducive to substitution. So I would go the substitution route. So it's just useful to have a couple different tools in your tool belt to find the same answer. Okay. All right, so let's go ahead and look at example 2. Okay, do you see, so approaching example 2, do you see opposites? No, unfortunately not, right? So this is where these problems start to get a little more tricky, is when I don't have opposites. How could, so we see 5x and 5x, right? That's what I want to kind of focus in on here. We see 5x and 5x. How could I make those opposites? How could I manipulate this situation and make 5x and 5x opposites? Yes?
I was going to say, like, since it's 2y, maybe making, like, giving one of the 2 to the y, like, making it 1 and 1.
We can't do that. We can't redistribute the x's and y's up to each other. That was a good thought, but we can't do that. Yep.
Do you multiply every number in there by -1?
Okay. So if I took 5x and I multiplied it by -1, it would now be -5x. And those would be opposites. And Josh hit on something very important. If I'm going to multiply one of the 5x's by -1, I have to multiply everything in its equation by -1, right? Because you guys remember the teeter-totter effect of an equation, right? I have to keep it balanced, so everything I do to one side I have to do to the other side. And that is exactly what we're going to do. So if I ever do not have opposites, I am going to force the hand and create opposites through multiplication. Okay, and we're going to do just a really simple one here, and then we're going to get into some more complicated multiplication in a few minutes. Okay, but Josh, you tell me, which one do you want to multiply by -1? Because it really doesn't matter in this instance.
The first one.
The first one, okay. So let's multiply the top equation by -1. Okay, so I'm going to draw a double line here showing that I'm not adding, I'm just rewriting. Okay. So now -1 gets distributed into every single piece, even the piece on the other side. So -1 times 5x is -5x. -1 times -2y is plus 2y. And then -1 times 3 is -3 on the other side of the equal sign. The second equation does not change at all, so I'm just going to rewrite it. 5x plus y equals -9. So nothing changed there. Okay, now that we've multiplied, now do we have opposites? We do, so let's go ahead and add down. So now this problem is just like example 1, right? Now that I have opposites, it's just like example 1. The x's are going to eliminate. 2y and y makes 3y down on the bottom. And then -3 and -9 make -12 on the other side of the equal sign. So now I just solve what's left by dividing by 3. And I end up with y equals -4. And remember, that is only half of the answer. So now I have to go back to one of the two original equations and plug in my -4. So which one would you guys like to use? Top or bottom? Bottom? Okay, sure. Why not? Okay, so if I take the bottom equation, I have 5x plus y, and now we know that y is -4, so I'm going to go ahead and put that there, equals -9. And now I'm just solving for the x that I have left. So opposite operation, add 4. So 5x equals negative 9 plus 4 is negative 5. Divide by 5. And x is negative 1. So make sure, be careful when you're writing your ordered pairs. Okay, it's always x comma y. So it's negative 1 comma negative 4. Okay? Can I get a comfort level of how you're feeling right now? 3, 2, 1, 0. Okay. Looking pretty good with twos and threes. Okay, good. So go ahead and try. Let's see. Let's do both of the try these, but let me prep you a little bit on number 2. Okay. So remember, I kind of glossed over this. I said it quickly, but you guys may not have picked up on it earlier in the lesson. Remember, I told you guys that we got to make sure that they're lined up: x's over x's, y's over y's, numbers over numbers. Number 1 is set up that way, so it's pretty straightforward. But can you see that number 2 is not lined up? Okay. Yeah, I'm just going to manipulate my equation. Okay, so I'm essentially going to take. So the bottom equation is good, right? I have x, y, number. I want to make the top the same way. So I need a way of taking this and putting it over here in front. So I'm just going to algebraically manipulate that, right? If I take anything across the equal sign, I want to do an opposite operation. So all I'm going to do is just add 3x over to this side. So now it's going to be positive 3x, positive 2y, and 5 on the other side of the equal sign. So now that's lined up with the existing equation. So now I'm just going to take and get rid of that one. So now that's my new system. Okay, so sometimes we have to do a little manipulation up front just to line them up. Okay? All right, so now that I kind of prepped you a little bit on number 2, go ahead and try these 1 and 2 together with your groups. Go ahead. Okay, here's the solution to number 1. And here's the solution to number 2. Okay, so looking at the next section, it says sometimes the variables will not drop out by simply adding or subtracting. Some teachers teach subtracting. I don't like to go down that route because then you get confused on when you're adding and subtracting. It screws everything up. So if the coefficients are different, as we've kind of experienced here, right, with 5x and 5x, we must multiply. Oops. There we go. Multiply. There we go. Okay. And then add in order to get the variables to drop out. Okay. So let's look specifically at example 3. So on example 3, I know you see the opposites of negative 22 and positive 22, but that's not going to accomplish anything, right? If I get rid of the numbers, I'm still going to have x's, I'm still going to have y's, and I'm not going to be able to solve for anything. So I'm not worried about that. But on the x and y side, do you see any opposites? Do you see anything that's the same that we can just multiply by negative 1? No. So this problem now gets a little more complicated than the previous ones that we've done. Okay. So let's think about this really quick. Could I multiply one of the equations by something to match up either the x's or the y's? Which one does it look like we would be able to do that with? The x's or the y's? The x's, right? Because the y's, if I look at the y's, 5 and 3, I'm not going to be able to multiply 3 by something to make it 5 unless it's a decimal, and that just gets messy. In order to match up the y's and make them whole numbers, I would have to make them both 15. So I would have to multiply both equations. That's not the route I want to go if I don't have to. But on the x's, I have 10x on bottom. What can I make the top x? What would I have to make it if I want opposites? It's going to have to be negative 10, right, in order to be opposite. So this 2x is going to have to turn into a negative 10x. What would I have to multiply by to make it a negative 10x? Negative 5. So I'm going to multiply this whole equation by negative 5. Okay, so now let's rewrite. So negative 5 times 2x is negative 10x. Negative 5 times 5y is minus 25y. And then on the other side of the equal sign, negative 5 times negative 22 is 110. The second equation doesn't change, so let's just rewrite that. 10x plus 3y equals 22. And now I have opposites, and now I'm ready to add down. Okay, so negative 10x and 10x is gone. Negative 25y plus 3y is negative 22y. Bring down your equal sign. 110 and 22 is 132. So I just have to divide by negative 22. And I end up with y equals negative 6. Okay, so that is half of my answer. Now let's figure out the other half. So do you guys want to use the top or bottom equation, original equation? Bottom, okay. So 10x plus 3 times my y value is negative 6 equals 22. All right, so I have 10x, 3 times negative 6 is negative 18. So I want to add the 18 over to the other side. I end up with 10x equals 40. Divide by 10, and x is 4. So again, be careful on your ordered pairs. Always make sure it's x comma y. So that would be 4 comma negative 6. So not much harder, okay? You just have to get creative sometimes about, or as far as what you're going to multiply by, okay? Look at the problem, study it. Don't just jump into something, okay? Study the problem a little bit. See what you think is going to be easiest as far as multiplying to make your equations the same, and then rock and roll with it, okay? Comfort level right now? Okay. Let's go to the top of the next page and work on try these A. So let's just do A, okay, for sake of time. So go ahead and do try these A together with your groups. Go ahead. Okay, so I don't have a set of opposites, so I need to create a set of opposites. 3 and 4 are not going to match up very easily for the N's. But for the M's, 4 and 2 will match up pretty easily, right? So I'm going to leave the top 4. So I'm going to make the bottom negative 4 by multiplying by negative 2. Okay, so top equation is going to stay the same. 4m plus 3n equals 13. Bottom equation I multiply by negative 2. So now I have negative 4m plus 8n equals negative 2. And now I'm ready to add down. So the 4m's are going to cancel. 3n and 8n is 11n. 13 minus 2 is 11, which gives me n equals 1. So there's half of my answer. Now let's use one of my 2 original equations to find m. I'd probably use, I don't know, it doesn't really matter. You guys have a preference? Top or bottom? Bottom? Okay. So I have 2m minus 4 times n is 1 equals 1. So 4 times 1 is obviously 4. So I'm just going to add this 4 over here. So I have 2m equals 5. Divide by 2. And m is 2.5. What?
What does the 8n come?
So here when I'm multiplying this bottom equation by negative 2, so negative 2 times negative 4n would be positive 8n. So then, I know somebody asked this question a second ago, but I'll say it just for the recording purposes. If you are not dealing with the x's and y's, it is generally most acceptable to put them in alphabetical order. So m, n is the way I would go here. So I do 2.5, comma 1. Oops. Guess I should put them in parentheses. There we go. Okay. All right. Now let's look at the big dog. Big dog. Let's look at example 4. Okay, so on example 4, do you see opposites? Nope. So we know we're going to have to multiply. So could I multiply 4 by something to make it 7? No. So the x's don't really work. Could I multiply 2 by something to make it 3? No. So the y's don't really work. So I'm going to avoid doing decimals because that just makes things really challenging. Okay? Yeah, what do you think, Brian?
Are we going to have to times both equations?
Yeah, we are going to have to multiply both equations. So let's talk strategy really quick. It does not honestly matter if you want to make the x's opposites or the y's opposites. But in this particular problem, there is an option that's easier than the other. What do you guys think? The x's or the y's? Which one do you think is going to be easier? Molly, you said y's. Why do you think the y's?
Because it's 2 and 3, so you can like place it.
Okay, so it is 2 or 3. You guys are generally more comfortable making those into 6 rather than making 4 and 7 into 28. But there's actually a little bit of a better reason for why the y's are a little bit easier here. Yeah, what do you think, Caitlin?
They're already opposites.
Yeah, they're already opposite signs, right? So now I just have to match up the numbers. So do you see how the x's are both positive, but the y's are positive, negative already? Mm-hmm. So the positive, negative is to my advantage. Now I just need to make them the same number. So let's go ahead and do that. So I'm going to make them 6 and negative 6. So that means I need to multiply my top equation by 3 and my bottom equation by 2. So let's go ahead and rewrite. So for my top equation, 3 times 4x is 12x. 3 times 2y is plus 6y. Equal sign, 3 times 14 is 42. Yeah. For my bottom equation, 2 times 7x is 14x. 2 times negative 3y is negative 6y. And then we see those opposites like we want. And 2 times negative 8 is negative 16. So now that I have the opposites that I wanted to see, now I can go ahead and add down. So 12x and 14x makes 26x. 6y and negative 6y eliminate. Bring down my equal sign. 42 minus 16 is 26. So now I can solve what's left. Divide by 26. And x is 1. Okay, I need to find the other half. I'll let you guys choose. Do you want the top or bottom equation? Top? Sure. No negatives. So we have 4 times the x value we just found is 1 plus 2y equals 14. Okay, so 4 times 1 is obviously just 4. So I'm going to go ahead and subtract it. So I subtract 4 from both sides. So that's gone. I'm left with 2y equals 18. No, sorry, 10. Went the wrong way, didn't I? 2y equals 10. Divide by 2. And y is 5. So then go ahead and make my ordered pair. 1, 5. Okay. So you can see it's just kind of an added layer. And you just have to get increasingly creative with what you're multiplying with, right? So start off, do you see opposites? No? Okay, take it up to the next level. Is there anything I could just multiply one of the equations by to make them opposites? No? Then I got to bump up to the next level. Okay, how could I multiply both equations to make them opposites? Okay. All right, any questions on elimination? Okay.